Right, so before we get to talking about the actual maths with this unit, with this topic, which is errors in measurement, just a little bit about your savvy of understanding where you are in an exam paper. Okay, this question is question 20. It's the last question on an intermediate tier paper, which means it's a grade B challenge question. So when you read it, and you read the cuboid has dimensions of 40 millimeters, 25 millimeters, and 12 millimeters, and then a little bit further down the line, it says 4 of these are stacked together as shown below. Write down the greatest possible value of the length A, and you think, well, the length A is obviously 40, and the length B is 2 lots of 25. Then you need some alarm bells ringing in your head, thinking, hang on a minute, that's not very challenging, that's a bit obvious. And you then need to think more about the question, because it would not be that easy even if it was the very first question on an intermediate tier paper. So you need to be spotting things, okay? And with this question, what you're spotting is that line there, that all of these measurements are correct to the nearest millimeter. Okay, that means they've been rounded to the nearest whole millimeter, the nearest whole number. So that 50 millimeter length or width of that cuboid, it could actually be smaller than that, because 39.7 millimeters rounds to the nearest millimeter to 40. So if you've got 40 millimeters, you need to think about what's the smallest value that would round. So if you've got 39 millimeters there and you've got 41 millimeters there, what's the value that would stop the measurement rounding to 39 and instead push it up to 40? And the answer is 39.5 millimeters. Anything smaller than 39.5, so say 39.4 or 39.3, to the nearest millimeter would round to 39. But if it's 39.6 or 0.7, it would round up to 40. So that 40 millimeter value there could be as small as 39.5. Now on the other side of that, what would be the cutoff between tripping down, rounding down to 40 or rounding up to 41? And the boundary there is 40.5. Everything above 40.5 rounds to 41, and everything less than 40.5 rounds to 40. So that could be anything down as far as 39.5, but it could be bigger than 40 millimeters. It could be anything up to 40.5. Now, although we know when we teach you rounding and you're learning to round numbers, that 40.5 actually rounds up to 41. But when we're talking about measurement, even though that is still true, when we're looking at the bounds, that the values round down to 40, we say that they're between 39.5 and 40.5. So similarly, 12 millimeters could be anything as big as 12.5 or as small as 11.5. And the 25 could be up as far as 25.5 but as small as 24.5. So this is what's making it a grade B challenge. Okay, you are spotting that it's a rounding, it's a measurement question that has been rounded. And then the other triggers that make you, or should make you, realize that this is a grade B question are these. Greatest, least. Write down the greatest possible value of the length of A. Well, we now know that A could be anything between 39.5 and 40.5, and its maximum possible value we would write as 40.5 millimeters. The greatest possible value of B, well, B is two of these laid end on end. So for that to be as large as possible, you want both of those cuboids to be at their maximum width, which would be 25.5. So you'd have 25.5 plus another 25.5, because we've got two of them. This is a non-calculator paper, so 5 and 5 is 10, 0 down carry 1, 10, 11. So the maximum possible length that B could be would be if both of those are at their maximum, which would be 51 millimeters. And then for the least possible value of C, well, I would want the height of those blocks to be at their minimum possible, which would be 11.5. So you'd have 11.5 plus 11.5, 10, 3, 2. So the least possible width would be 23 millimeters. So you need to have that awareness within the paper. Hang on, this looks too easy to be even on an intermediate tier paper, let alone grade B. I need to be looking to see what that is. And once you get this, it's an easy question, but you just need to be spotting it. So let's have a go at some more. So Sanjay stacks 3 boxes in a pile. The heights of the boxes are 25 centimeters, 36 centimeters, and 47 centimeters. And here's the trigger. This makes it grade B. They are all measured correct to the nearest centimeter. So 25 centimeters. So if we just think about this down here for a minute, just to remind ourselves. To the nearest centimeter, it's going to be 25, 26, 24, 23, and so on. The boundary between rounding up to 25 is going to be 24.5. And the boundary for measuring down to 25, to the nearest centimetre, would be 25.5. So basically, if it's being rounded to the nearest centimetre, it's going to be a half centimetre above and below that. So 25 centimetres, max would be 25.5, min 24.5. The next one is 36 centimetres, so that max would be half a centimetre bigger, 36.5, min 35.5. And the 47 centimetre one could be anything up to 47.5 or down to 46.5. So again, maximum and minimum. So they're all measured correct to the nearest centimetre. What's the greatest possible height of the stack of the 3 boxes? Well, that greatest possible height will be when each box is at its maximum possible height. So that will be, and I'm not sure whether this was on a calculator or non-calculator paper. So just for speed, we'll use a calculator. But what we're adding are the 3 maximum heights. So on my calculator, 25.5, 36.5 and 47.5. So 109.5 centimeters is as large as that could possibly be. So there's that other trigger there. What's the greatest? Question 2. A rectangle measures 38 centimeters by 26. Each measurement is correct to the nearest centimeter. What is the least? It's a grade B question. So if we consider, now for this, we got a rectangle. So we've got 38 and 26. So to find the area, we've got to multiply 26 by 38. But because I've got a rounded measurement to the nearest centimetre, so 38 centimetres is going to be half a centimetre bigger, is its maximum, half a centimetre smaller for its minimum. The width, 26 centimetres, will be half a centimetre larger at its maximum, so 26.5, and as its minimum, half a centimetre smaller, 25.5. For that area to be as small as possible, I need those sides to be as small as possible. So for the minimum area, it will be 25.5 multiplied by 37.5. So 956.25 square centimeters for the units for area. So again, once you spot it, it's not a particularly challenging piece of maths you've got to work with. Question 3. Michelle owns a cafe. She stacks coffee mugs as shown in the diagram below. Michelle measures the height of each coffee mug as 12 centimeters. Here we go, correct to the nearest centimeter. Each stacked coffee mug creates 4 centimeters extra height, correct to the nearest centimeter. Michelle knows that the vertical height between the two shelves is exactly 39 centimeters, so that hasn't been rounded as shown below. Can Michelle be certain that she will be able to place one stack of 7 coffee mugs between the two shelves? Give a reason for your answer. You must show all your working. Right, so we know that because these have been rounded, their heights, their combined heights could vary. So in order to be sure that they'll fit, and that is exactly 39, we want to make sure that their maximum possible heights is less than 39. So need to check that max possible height when stacked is less than 39 centimeters. So the gaps, 4 of them, correct to the nearest centimeter, means that that's got a max possible of half a centimeter higher and a min of 3.5. The 12 centimeter has got a max of 12.5 and a min of 11.5. Now we want those to be maxed. Yeah, we want to know that even if each of those mugs tall as possible, 12.5, that they'll still only come to 39. So she wants to stack 7 coffee mugs. So 7 coffee mugs will have 1 complete mug. So we'll have 1 at 12.5 plus 6 more stacked on top with that 4 centimeter gap. So plus 6 lots of 4.5. So the 12.5 is this first one, and then we got 6 lots of 4.5. So let's work out what that comes to. So 12.5 plus 6 lots of 4.5, 39.5 centimeters. So it's possible that those 6 mugs are going to be greater than the gap between the shelves. This is more, so she can't be certain. We're not saying that it can't happen, because they could all be at their minimum, in which case they might fit, or a combination of the two. But if it happens that they're all at 12.5, then it's not going to fit. Question 4. So the first bit is different. So there were 71,532 supporters in the stadium watching the match. A newspaper headline writes this number of supporters correct to 2 significant figures. So it's a rounding question. It's not a measurement question. Which of the following numbers should appear in this headline? So to 2 significant figures, when you round to significant figures, you start counting at the leftmost digit, because that's got the highest power. If you think that's units, tens, hundreds, thousands, 10,000s. So that 7 is actually worth 70,000 people. That is worth 10,000, and so on. 1,000. So the 2 most significant figures are these 2. So because of that, my answer is either going to be 71,000 or it's going to be 72,000. Okay, that's my number line. Those are rounded to 2 significant figures. Halfway between there is 71,500. This is above that, so it's going to round closer to the 72,000. So you're looking for 72,000. Okay, the one common wrong answer with that is the 72, whereas you correctly get the right 2 digits, but you forget that they have to keep their place value, so they have to stay in those thousands positions and 10,000. Now we move on to the actual bit that is to do with our work. The rugby pitch at the stadium is measured. On the diagram below, each measurement is given correct to the nearest 10 centimeters. What is the least possible value of AB? Okay, so this one's a bit trickier because it's telling us that it's rounded to the nearest 10 centimeters. Okay, so we've got a 10 meter measurement, and there's our other trigger, least. Okay, so that 10 meters, well, first of all, let's think of it in centimeters. There's 100 centimeters in 1 meter. So in 10 meters, there's going to be 10 lots of 100, 1,000 centimeters. And if we're rounding to the nearest 10 centimeters, that means our number line is going to be counting 990, 1,000, 1,010, and so on. So each of those are our 10 centimeter jumps, and if we are rounding to the nearest 10 centimeters, then it's going to the divider is going to be 5 centimeters either side. So 995 and 1005. If I've got a measurement of 998, to the nearest 10 it's going to round to 1000. If I've got a measurement of 1002, to the nearest 10 it's going to round to 1000. So that is going to be as small as 995 centimeters or as large as 1005 centimeters. I've turned it into centimeters because that's the rounding, but what we're working with here needs to be in meters. So for the least possible size, that is going to be 995 centimeters, which is 9.95 meters. So that distance is 9.95 meters. That distance is also 9.95 meters. And then I've got the 100 meters below. And it's the same thing here. The 100 meters, if you think about it, 100 meters is going to be 100 times 100, so that's another 2 zeros. So it's going to be 10,000 centimeters. The minimum is going to be 5 centimeters less than that. So the minimum and the maximum of 5 centimeters either side would be 10,000 minus 5, which is going to be 99,995. Okay, 100,000. So 4 zeros minus 5 is 9939s. Sorry, I got 19 too many. Centimeters, which divide by 100 is 99.95 meters. So this distance is 99.95 meters. So the minimum possible length of AB would be 9.95 plus 99.95 plus another 9.95. So 119.85 meters. So that was a bit trickier because of the rounding was in a different unit to the measurements, right? So they can make these harder. The last few years they've been a bit more straightforward than that, but we need to practice that as well. So the final question. Tiles are laid end to end without any gaps along one edge of a driveway. The length of each tile is 8.5 centimeters, correct to the nearest millimeter. So there's our grade B trigger. The length of the driveway is 126 meters, correct to the nearest meter. Tiles are sold in boxes of 12. Calculate the greatest number of boxes of tiles that would be needed. So I've got a driveway that's 126 meters, correct to the nearest meter. So this driveway is 126 meters to the nearest meter. So this is like the earlier questions. That could be as big as a half meter either side. So 126.5 meters, or it could be as small as 125.5 meters. Now we are going to put these tiles along the edge of that driveway, and we want to see how many of them will need to fit in there. And if we want the worst case scenario for the boxes we've got to buy, then we want the drive to be as big as possible, but we want the tile to be as small as possible to have to fit the most of them in. So if we consider that tile, it's 8.5 centimeters, correct to the nearest millimeter. So let's change that into millimeters. So that's going to be 85 millimeters. So that could be as big as 85.5 millimeters or as small as 84.5 millimeters. I then need to have this all in the same units. So rather than having that in millimeters, I'm going to divide by 10 to turn it back into centimeters. So that's going to be 8.55 centimeters, and that's going to be 8.45 centimeters. To work out how many you're going to fit in, I want to change these into centimeters. There's 100 centimeters in a meter, so that's going to be 100 times that in centimeters, which will be 1